After studying the procedure to trace Cartesian curve, let us see some examples. The first example is trace y square into x minus a is equal to x square into 2a minus x. Now there are 5 points. First point is symmetry, second origin, third points other than origin, fourth asymptotes, fifth region of absence, and last one is shape of the curve. Okay, so we'll start first point, symmetry. Symmetry. Now as this curve, if we see the equation, in equation the power of y is even and only even. If power of y is even and only even, then curve is symmetric about x-axis. So here the symmetry, it is about x-axis. So curve is symmetric about x-axis. Okay. Now the second point is origin. Second point is origin. How we check whether curve passes through origin or not? Put x is equal to 0, y is equal to 0 in the given equation. So when I substitute x is equal to 0, y is equal to 0 in this equation, then LHS it is 0, RHS it is 0. Therefore, equation gets satisfied and therefore equation gets satisfied and therefore given curve passes through origin. So curve passes through origin. Now once curve passes through origin, the next work is to calculate equation of tangent at origin. And how to calculate equation of tangent at origin? So we have written the method that equation of tangent at origin can be obtained by equating the lowest degree term to 0. So now we will consider the equation x y square. Consider x y square minus a y square is equal to 2ax square minus x cube. Now what is the degree of first term? It is 3. Degree of second term, it is 2. Here also degree 2 and here degree 3. So in this equation there are two terms which have least degree and which two terms? So I will write equating lowest degree term to 0, equating lowest degree term to 0, we have minus ay square, this is on LHS, and the term which have degree 2 on RHS I will shift towards LHS. So minus 2a x square is equal to 0, and this implies I can take minus a common. So minus a into bracket y square plus 2x square is equal to 0, and this implies y square plus 2x square equal to 0, and this implies y square is equal to minus 2x square, and therefore y is equal to plus or minus root 2x and square root of minus 1 is r. Okay. So here equation of tangent at origin. So these are the tangents at origin, and these tangents are imaginary. These tangents are imaginary, and therefore origin is an isolated point. Origin is an isolated point. Is it understood? So in origin we got origin is present for the given curve, and at origin tangents are imaginary, and therefore origin is an isolated point. Now we will go towards third point, that is points other than origin. Points other than origin. How to get points other than origin? Put x is equal to 0, you will get point on y-axis. Put y is equal to 0, you will get point on x-axis. Now see, where x is equal to 0, if I substitute in the given equation, RHS is 0. Here 0 minus a, it is a minus a. So minus ay square is equal to 0. Minus ay square is equal to 0, and this implies y square is equal to 0, and therefore y is equal to 0. So when we substitute x is equal to 0, we got here y is equal to 0. It means 0, 0 is the only point of intersection with y-axis. Now to get point on x-axis, put y is equal to 0 in the given equation, then what will happen? LHS is 0. So 0, this implies 0 is equal to x square into 2a minus x, and therefore x square is equal to 0. 2a minus x is equal to 0. This implies x is 0, and here x is equal to 2a. So by putting y0, we got two values of x. One value is x is 0, and second value is x is equal to 2a. And therefore, the points of intersections are 0, 0, 0, 0, and 2a comma 0. 2a comma 0. So there is only one point other than origin. There is only one point other than origin which is on x-axis. Okay? Now the fourth point, it is asymptote. But before that, here we got 2a comma 0 is the point other than origin. So next work is to calculate equation of tangent at 2a comma 0. How we calculate tangent at 2a comma 0? There are two methods. One is either shift of origin, and the second method is calculation of derivative. So here what we do, we use shift of origin to get tangent at 2a comma 0. For using shift of origin, we use the transformation as put x is equal to capital X plus h and y is equal to capital Y plus a. But here we have to shift the origin to the point 2a comma 0. So we use the transformation as x is equal to x plus 2a and y is equal to y plus 0. So when I replace small x by capital X plus 2a in the given equation, we get capital Y square in bracket small x minus a, so it is x plus 2a minus a is equal to x square, so here it is x plus 2a bracket square into bracket 2a minus x, so 2a minus in bracket x plus 2a. Okay. Now if I simplify, so y square into, here it is x plus a and is equal to x square plus 4ax plus 4a square. So this is first bracket, and in second bracket 2a will get cancelled, so into minus x. Now after using these two transformations, our origin, now it has got shifted to the new origin. And what is that new origin? It is the point 2a comma 0, and it is in new system, that is capital XY. So now what we will do, to get tangent at origin, what we do, equate lowest degree term to 0. So here Now x into y square degree is 3, a into y square degree is 2. So here degree 3 and degree 2. On right hand side, capital X into x square degree 3, capital X into x degree 2. Here this is the constant term, so x into constant term degree is 1. So here lowest degree term is minus 4a square into capital X is equal to 0, and this implies capital X is equal to 0. This implies small x minus 2a is equal to 0, and therefore x is equal to 2a is an asymptote parallel to y-axis. So the asymptote is x is equal to 2a. Okay, sorry, the tangent is x is equal to 2a. So x is equal to 2a is the equation of tangent at 2a comma 0. Now the next point is asymptotes. Asymptotes. How we check whether asymptote is present for the given curve or not? The condition is if the coefficients of highest power of x is constant, then asymptote is absent. If the coefficient of highest power of y is constant, then asymptote is absent. If the coefficients of highest powers of x and y, if they are variable, then equate that variable to 0, and that is nothing but equation of asymptote. So here in this equation, if I write the equation, so y square into x minus a is equal to x square into 2a minus x. So this is nothing but x y square minus a y square is equal to 2a x square minus x square. Now see here, highest power of x is x cube, but its coefficient is minus 1, and minus 1 is a constant, and therefore asymptote parallel to x-axis is absent. What is the highest power of y? Highest power of y, so it is at 2 terms. This term contains y square, and also this term contains y square, so I can write this as x minus a into y square is equal to 2ax square minus x square. So here highest power of y is y square and its coefficient is x minus a, and therefore asymptote parallel to y-axis is x minus a is equal to 0. This implies x is equal to 0. Is it understood? So there is no asymptote parallel to x-axis because coefficient of x cube is constant, and there is only one asymptote parallel to y-axis, and that can be obtained by putting coefficient of y square to 0. So that is x minus a is equal to 0, and which implies x is equal to a. Okay. Now we will move towards next point, that is the region of absence. The fifth point is the region of absence. So there are many methods to check the region, but whatever method we have decided, the first step is plot the points of intersection. So first I will draw x-axis and y-axis. The step number 1 is plot the points of intersections. So in this curve we got origin is one point of intersection, and 2a comma 0 is the second point of intersection. 2a comma 0 is the second point of intersection. Also, for the given curve, one asymptote is present, and that is x is equal to a. So if asymptote is present, then asymptote itself is one of the partition. So this is x is equal to a. Now third point is define the partitions, but before defining the partition, we'll have to draw the partitions. So as point of intersection is on x-axis, draw the line through the point 2a comma 0. So how many partitions we got? So this is 1, this is second, this is third, and this is fourth. So total 4 partitions we got. Now we will define each partition. As this point is origin, this point is a comma 0. So this partition is x less than 0. This is 0 less than x less than a. This is a less than x less than 2a, and this partition is x greater than 2. Okay. Now in each partition we will choose one value of x, and accordingly we calculate y square. Now we will see some calculations. Now we choose the value of x from each partition, and accordingly we will calculate y square. Now from first partition I will choose the value of x as minus, because the first partition is x less than 0. So therefore I have chosen value of x as minus. According to given equation, what is the value of y square? Value of y square is x square into 2a minus x divided by x minus a. So when x is minus a, this is positive. 2a minus x, but value of x is minus a. So minus of minus it will be plus, so this is positive. And when x is minus a, this is negative. And therefore positive divided by negative, and therefore y square is negative. If y square is negative, curve is absent in this partition. So in whole partition curve is absent. The next partition is for 0 less than x less than a. We will choose the value of x as half a, that is a by 2. When x is a by 2, if I substitute in this equation, so this is positive. 2a minus half a, this is positive. But here a by 2 minus a, so that is half a minus a, so this is minus half a, this is negative, and therefore y square is negative. Therefore in second partition again curve is absent. Now third partition, for a less than x less than 2a, choose value of x as 3 by 2a. 3 by 2a, it is 1.5. When x is 3 by 2a, if I substitute here, this is positive, this is positive, and this is also positive, and therefore y square is positive, and therefore curve is present in this third partition. And for last partition, for x greater than 2a, choose value of x is 3a. If I choose value of x is 3a, this is positive, this is negative, this is positive, but whole ratio is negative, therefore y square less than 0, and therefore curve is absent in this fourth partition. Is it understood? So curve is present only in third partition. Okay. Now the overall, what we studied in these discussions, that the given curve is symmetric about x-axis. For the given curve, origin is present, but that origin is isolated point. For the given curve, the points other than origin is 2a, 0, and at this point, tangent is x is equal to 2a. There is one asymptote which is parallel to y-axis, that is x is equal to a, and this is what the region of offsets. So only third region curve is present. So by considering these above points, these all points, we will draw the curve. So last point is shape of the curve. Shape of the curve. Now, so while tracing the curve, first draw coordinate system, x-axis, and y-axis. Now the first point, symmetry, we will see at the last after tracing the curve. The second point is curve passes through origin. So origin is present on the curve, but at origin, what is the tangent? Yes, there is imaginary tangent, and imaginary tangent means what? Origin is an isolated point. So if origin is an isolated point, we represent origin as a dot and then a small circle around it, and now we give name for this origin as isolated point. Isolated point. Okay. Now the points other than origin, it is 2a comma 0. So this is origin 0 comma 0. Suppose this point is a comma 0, and suppose this point is 2a comma 0. So this point is 2a comma 0. At this point, what is the tangent? Tangent at 2a comma 0 is x is equal to 2a. So x is equal to 2a, it is the line parallel to y-axis. So I will draw here. This is the line which is parallel to y-axis and passing through the point 2a comma 0. Okay. Now, if at this point this line is tangent, then curve may have the shape either like this or like this. But in region of absence, before 2a curve is present, but after 2a curve is absent. So whatever curve I have drawn on this side, I will erase this. Okay. So the part of the curve lies on this side, and that is to be third partition. Okay. Now the fourth point is asymptote. So what is the asymptote? It is x is equal to a. So I will draw the asymptote. Asymptote, it is a line. X is equal to a. So this is the asymptote. If this line is asymptote, the possible curves are either like this or like this, either like this and again like this. But before a, because this line is x is equal to a, before a in second partition curve is absent, and after a in third partition curve is present. So in second partition curve is absent, therefore I will erase this. Again I will erase this. Why I have drawn asymptote and why I have drawn the curve like this? Because asymptote, it is a line which touches the curve at infinity. So at infinite distance, this line touches the given curve. Now only in third partition curve is present. Here curve is absent. Here curve is absent. Here also curve is absent. So now we will draw these two curves in same partition. So the shape of curve is like this. And as it is a symmetric about x-axis, whatever we have drawn above x-axis, same we have to draw below x-axis. So this is the final shape of the given curve. Okay.